Well, today we are going to discuss about the scalar and vector. And this is very important chapter. If you are very clear with the vector concept, you think that your 50% of the physics is over. Let us first start with the first term, that is what is scalar or what are scalar quantities. Scalar quantities are those quantities which has only a magnitude and no specified direction. Just a second. Scalar quantities. Scalar quantities. So these scalar quantities are those physical quantities which has only the magnitude, and there is no specified direction. So what will be the examples? Let us check out examples. So the first example is distance. Distance is a scalar quantity. Is it? What about the mass? Mass, it is a total content of matter. It is also a scalar quantity. It doesn't have any direction. Third, let me take it, speed. So this is a scalar quantity. Any doubt? And Anvesha?
No, sir. No.
It's okay?
Yes, sir.
I'm erasing this. Yes, you can find the notes here for your reference. Next come is a vector quantities. Vector quantities. Vector quantities. Vector quantities are those quantities which has both magnitude as well as direction. For example, suppose this is a block lying there and you are applying a force F, say of 10 Newton. So when you are applying a force of 10 Newton, you see you have a magnitude 10 Newton and you also have a particular direction. So since there is a magnitude as well as direction, so what you will call force to be a vector quantity. Do you agree? Dear?
Yes, sir.
When I take displacement, if I say displacement is a vector quantity. Yes, displacement, it is the shortest distance between the initial, I for initial, and the F for the final. And it is directed from the initial. Say the displacement is 10 meter. So it has a magnitude as well as direction. So I will call it to be a vector quantity. Third, it is a vector. Vector I am telling. Velocity. Velocity is also a vector quantity. Any problem?
No,
Yes,
sir.
dear? No. But there are some physical quantities which are very confusing. Let us see it one by one. The number one is time. What is time? Time is a scalar or vector. You see, suppose you are 15-year-old now. After 1 year, you will become 16-year-old, then 17-year, 18-year, 19-year, like this way. So you can say that, okay, sir, you see, it has a magnitude and it also have a direction. It's propagating in a forward direction. So is the time a scalar or a vector? I will call it to be a scalar. Still, I will call it to be a scalar quantity. Why? Because time cannot be reversed. Time cannot be reversed. Since it cannot be reversed, it will not satisfy the property of the negative vector. So time is a scalar. The time when, if you will invent a time machine and you will be able to go back in the time, obviously after that I will call the time to be a vector quantity. But now I will call it to be a scalar because it is not satisfying all the property of the vector. It is not satisfying the property of the negative vector. So I take the time as a scalar quantity. Any problem? If you have a problem, you can
No,
ask.
sir.
Okay.
No, sir.
The next is current, electric current, CURRENT, current. Electric current. You will say, sir, just wait. Electric current has a magnitude. Say 5 ampere current is flowing. It has also a direction. It is directed from the high potential to low potential. And it can also be reversed. Yes, if you will change, if you will reverse the terminal of the battery, the direction of the current will be reversed. I do agree with you. But still I call it to be a scalar. It is called as a scalar because it do not satisfy law of vector addition.
Excuse me, sir.
It do not satisfy the law of vector addition. Yes, just a second. Yes, dear, ask question. What you are asking?
Sir, may I write it down? The things which you are writing in the
Take a
board?
screenshot. Take a screenshot.
Okay, sir. That will be helpful. Okay, sir.
Yes, you have taken. Turn your mic on, dear.
Yes, sir.
Is it clear? Whatever I am telling you, is the things clear to you or not?
Yes, sir.
Because these questions are put in the MCQs.
Okay, okay. Yes, sir.
I'm erasing. May I erase?
Yes, sir.
Okay. It has been erased. So that goes the time. What about the pressure? A time and current is gone. Third is a pressure. Pressure. What is pressure? Pressure is scalar or vector. Pressure is also scalar. Why? Because of Pascal's law. Because of Pascal law. What is this? When a pressure exerted on an enclosed fluid, it is transmitted equally and undiminished in all direction. What I said you? In all direction. That is, no specified direction is there. Isn't it? Since there is no specified direction, I term the pressure as a scalar. The last one is a work. Very common one. Work. The most interesting thing is work is a dot product of two vectors. Still it is a scalar. Because the dot product of two vector is a scalar. Is it okay with you? Am I okay with you?
Yes, sir.
Okay. So what we have done, we have gone with the definitions of scalar and vector, and we have done the classification of vectors. I'm stopping this